Hi everyone. So this is a lesson on multiplying and dividing numbers in scientific form and adding and subtracting numbers in scientific form. So let's get started. Here's our first problem. All right, when you're multiplying, you can multiply in any order. So I'm going to rewrite this problem. This means the same thing as 4 times 6 times 10 to the 6th power times 10 to the 7th power. Well, 4 times 6 is 24 times 10 to the 6 times 10 to the 7. These are powers with the same base 10. Keep the same base 10 and add the powers. Okay? So it's 24 times 10 to the 13th power. But this is not in scientific form. And we like to give our answer in scientific form. Okay? This does not fit the definition that says A must be a number 1 or greater, but less than 10. Okay, so we need to move the decimal from here and put it here. So we're going to make the number smaller by a power of 10 when we do that. So if we make this number smaller by a power of 10, we have to make this larger by a power of 10. So we just add 1 here, and then we get 14. So now we have the same answer, but in scientific form. All right, let's try the next one. So we can rearrange them, change the order around because this is a multiplication problem. Multiplication is cumulative. So this means the same thing as that. All right, 5 times 3 is 15 times 10, keep the base 10, and add the exponents, and we'll have 2. But this is not scientific form because 15 doesn't fit this definition of A. We need to move the decimal from here and put it right here. So we can move it. We'll get 1.5, but we just made this smaller by a power of 10. So we have to make this one here larger by a power of 10. So we just add 1. And that gives us 10 to the 3rd. So if you make the front number smaller, you have to make the back number bigger. So they go in opposite directions. All right, let's look at the next one. So I'm not going to rearrange anything. I'm just going to go ahead and show you what I'm multiplying. I'm multiplying 6 times 2. That's 12. And I'm going to keep the same base 10 because I have base 10 here, base 10 here. And I'm just going to add -6 plus -3 gives me -9. Okay. This number is not in scientific form either. So we're going to have to move the decimal from here to here. So we'll end up with 1.2. I just made it smaller by a power of 10. So if I make the front number smaller by a power of 10, I have to make this power here larger by a power of 10. So just add 1. So that'll give us -8. And that's it. We have the same answer, but in scientific form. All right, let's do the same thing here. I'll multiply these two numbers together, and that'll give me 2.4 times powers with this same base 10, so I'll keep 10. 4 plus 6 is 10. And this answer is already in scientific form, so I don't have to do any more work. All right, now let's divide. All right, so divide out the numbers. 12 divided by 6, let me erase that and try to circle this a little bit better. Okay, 12 divided by 6 is 2 times, and then you want to divide these out. That means you keep the same base, and you just subtract exponent. 4 minus 3 is 1, and we don't have to put a 1 there because every number is to the power of 1. We just don't write it. So if we simplify that, that just gives us 20. Okay, we're going to divide the numbers here first. 30 divided by 5 is 6 times, and then we'll divide out these powers with base 10. That'll give us 10 squared. We can simplify that. 10 squared is 100. So then our final answer is 600. When we have big powers, leave them alone. But when the powers are really small, we're going to end up with not such a big number. Go ahead and simplify. Okay, so let's divide these out first. We'll get 0.4 times, then divide these out. Keep the base 10. 6 minus 2 is 4. Okay, now is this in scientific form? Does this fit the definition that A must be a number, 1 or greater, but less than 10? Okay, it has to be 1 or greater. Is this 1 or greater, 0.4? No. So we need to make this bigger. So we need to take the decimal and go one place to the right. So we're going to end up with 4. We just made 0.4 bigger by a power of 10. We made the front number bigger. We got to make the back number smaller. Think about it that way. So this will be 10 to the third. Now, it's the same answer, but in scientific form. Okay. All right, here we're adding. Okay, now we're adding. When you're adding, it's like adding fractions. Can you add fractions that don't have the same denominator? No. You have to match the denominators. Well, when you're adding numbers in scientific form, you have to, first of all, make sure you have powers with the same exponent. Okay? So what I like to do is always raise the power with the smaller exponent to match the one with the higher exponent. So we want to match this power right here. So that means this, we have to add 2 here. Okay, but if I just made this power larger, okay, I've got to make this smaller, this number smaller. Because basically I multiplied by 100 here. So if I added 2, that means I have to move the decimal from where it's at right now behind the number. I have to move it 2 places to the left. 1, 2. Giving me 0.03 times 10 to the 3 plus 2 is 5. Okay, now we have matching powers. Now we're going to be able to add the numbers and keep the matching power. So the next thing you're going to do is add the numbers. 2 plus 0.03 is 2.03. You add them. And then you keep, you don't have to do anything. You keep your matching powers. You just keep them. You don't do anything. You match them and you keep them. That's it. All right, let's try the next one. All right, so we want, I think this is a repeat. So we'll cancel that one out. This is a repeat. All right, go down here. All right, so we want this to go up to 7. So we're going to add 1 here. That means we have to move the decimal from here and put it right in front. So it's going to be 0.2. Okay, and then I just added the 1 because I want it to match here. So 10 to the 7th power. Okay, so I made the adjustment. I added 1 here. That means I made this bigger by a power of 10. I've got to make this smaller by a power of 10 to keep things balanced. Okay, so I'll put a 0 right here. So that's the same same number, but different form. Okay, now that we have matching powers, we can just add our numbers. We can add this number to this number here. So now let's do that. So 5 plus 0.2 is 5.2 times, keep the same power. Okay, that's it. All right. So this is the higher power. We're going to keep that. We want to increase this by 1, but I just made this bigger by a power of 10. I got to make this smaller by a power of 10. So the decimal is going to move over here. It's going to be 0.13. Let's put a 0 in front. Times 10. 4 plus 1 is 5. Plus, okay, and now we're going to be able to add them. Now that we have matching powers, we're going to be able to add them. Okay, so you're going to add your decimals. Okay, 2.4. Line up your decimals, 0.13. Add these. Let me use a different color. Okay, so 2.4.13, and we add these. Let's put a 0 here. So you have 3, 5. So then you're going to get 2.53 times that matching power. That's it. All right, let's do the next problem. Okay, so let's get matching powers. So we have 5 here. We need this to be 5, so we'll add 1 here. So I just made this number here bigger by a power of 1. That means I have to move the decimal from here and put it here. It's going to be 0.4 times 10 to the 5th power plus 1.2 times 10 to the 5th power. Okay, now I can add these together. 1.2 plus 0.4 is 1.6. So I have 1.6 times the matching power, 10 to the 5th. All right, let's go to the next problem. Why don't you try it? I'll let you get a head start. Since this is 5, we want this to be 5, so you have to add 2 here. Because you added 2 here, it means you made it bigger by a power of, by 100. Okay, so you have to do the same thing here. You have to make it smaller by 100. So you're going to move the decimal 2 places to the left. So you end up with 0.032 times 10 to the 5th. All right, now you just combine these together. 1.5 plus, line up your decimals, 0.032, add them. Put 0 here, 0 here, 2, 3, 5.1. So 1.532 times your matching power, 10 to the 5th. And that number is in scientific form, so we don't have to change anything. Okay, so I forgot to give us a subtraction problem, so I'm going to come up with a subtraction problem right here. Let me erase this. I'm going to erase this so I can have more workspace. So I'm erasing this. And I'll erase that. And the answer was, sorry, for this was 1.532 times 10 to the 5th power. Okay, so now let me come up with a practice problem for us where we're subtracting. Okay, 5 times 10 to the 4th power minus 2 times 10 to the 3rd power. Oops, I didn't need to put negative. 3rd power. Okay, so we need matching powers first. So this has got to go up 1, so we add 1 here. Well, we made this number bigger by a power of 10. We got to make this smaller by a power of 10. It's going to move the decimal from here to here. Okay, so then we end up with 0.2 times 10 to the 4th power. And this one stays the same. All right, so you're going to take 5 and subtract 0.2 from it. You're going to get 4.8 times your common power, 10 to the 4th power. That's it. Let's try another one. Subtract again. Here's one subtraction problem. Here's another subtraction problem that we'll do. How about 4 times 10 to the 5th power minus 3 times 10 to the, we'll do 4th power. It can be any power. Okay, so the powers have to match, but I wanted it to be similar to the one we did already. So we need matching powers. So add 1 here, because we want to match the higher power. So if we make this bigger by a power of 10, we got to make this smaller by a power of 10. So move the decimal 1 place to the left. And then we'll end up with 0.3 times 10 to the 5th power. And this one stays the same. Okay, so 4 minus 0.3 is going to be 3.7 times, keep the matching power, 10 to the 5th. Okay, and this concludes this lesson on multiplying, dividing, adding, and subtracting numbers in scientific form.